So as you can see in the questions number 1, can someone confirm whether you guys can see the slide and also can hear my voice?
Yes, Miss.
Okay. So as you guys can see from the slide, so the questions give us informations like the range of the data value and also the range of the length of the extension. So in the questions, it actually asks us to find three things. The first one is determine the moment developed at A as a function of x and theta. And the second thing that the question asks is the values of both x and theta developed at the maximum possible. And the third one is the actual value of the moment after you guys get the value of x and also the theta. So basically in these equations, it just wants us to find the moment. So you guys can use a formula equal to force times with the distance. So since the first item that it asks is actually moment developed at A as a function of x and theta, that means that you guys just need to use the formula without solving the x and theta. And then after that, you guys find the value x and theta, and then you guys find the value of the moment. So try to take 10 minutes to solve the problem, and then we will discuss uh, how can we get the answer. Okay. Okay, so let's discuss our questions for number 1. So if you redraw the diagram, so it's supposed to be triangle like this with with theta value here, and the distance between A and B, it has to be 9 minus 1.5 plus x. Because as you can see from the picture, the diagram, the A actually started after the 1.5 meter. So that's why you have to minus with 1.5 meter. And here is the D, the distance that perpendicular to the force. So this is where your force are. Okay. Okay, so we will solve the first request that the question asks us to do, which is moment developed at A as a function of x and theta. So has anyone solved this problem? Can you guys share with me the answers so that we can discuss to see whether you guys managed to get the answer or not? Has anyone solved the first part yet? If you do, you may share in the chat. So, for the first part, so since it requires us to have the moment, so you guys can use this formula, m equal to ft. Okay, so in this case, the value f L or the value of f is not given. So the only available information is the mass, which is 120 kg. So in this case, we can find value the force downward by using this information, which is 120 times with 9.81 times with the gravity, and there should be negative for the force here because you define the moment to be anti-clockwise and the force is actually downward, which is against the directions of the moment. So there should be negative here. And then the value of t. So the value of t should be this part because this is in scalar. So the value of t have to be perpendicular to the force. So here is actually here the d value is 7.5 plus x times with cos theta. So you just plug in the value into here. And then you guys simplify the value. which will give us the answer. Sorry, it should be negative at the front here. Okay. Okay. So this is the answer actually. Negative 1.18 cos theta times with 7.5 plus x kilonewton meter. So this is actually in the direction of counterclockwise. So in case of direction of clockwise, you may wrote it as plus positive 1.18 cos theta 7.5 plus x. So either one is actually correct, but you have to define the directions which way so for it to be correct. So in this case, counterclockwise is negative 1.18 cos theta 7.5 plus x kilonewton meter, and in terms of clockwise direction is positive 1.18 cos theta 7.5 plus x kilonewton meter. So for first part, this is actually the answer because it asks us to find the moment as a function of x and theta. So you guys don't have to find the value of them yet. So anyone has any problem with this part? So do you guys understand for this part? If you guys have any questions or don't understand, you may stop me so that I can explain to you guys. So I assume everyone is okay with the first part. So then I will proceed with the second part, which is we have to find the value for both x and theta, develop the maximum possible moment. So even though the questions give us range, the theta value between 0 to 90 degree and x between 0 to 5 meter. So you guys actually has to see what's the conditions that the questions want. So it wants the moment to have the maximum possible value. Yes, the value is actually within the range, but you there is only one answer within the range. So what makes the moment to have possible moment? So in this case, does anyone knows? This question actually quite similar with the example 3 in your lecture. I think you guys should have known this. Okay, wait. Miss bukan anti-clockwise positive ke? Oh, actually, okay. It's true that the moment direction is anti-clockwise. You define the moment to be anti-clockwise, but the whole equation should this whole equation the direction actually has to refer to the direction of the movement. Yeah, so as you can see, even though m equal to fd, so Okay, the moment is actually at point A here. It's supposed to be like this, right? This is the moment direction anti-clockwise. But as you can see, the force here is actually pointing downward because it is mass times with gravity, because gravity is always pointing downward. So as you can see, here is downward, and the moment is actually counterclockwise, facing upward. So that's why if you define the moment to be anti-clockwise, so the force pointing downward should be negative. But if you define your moment to be uh, from starting, you define the moment to be clockwise like this, and you see the force is pointing downward. So that's then the value of the F should be positive. But since the direction of the F and the moment actually opposite to each other, so it should be negative here. Uh, is that clear, Farasha? Okay. Okay. If then we proceed, uh, the maximum possible value, moment value. So in this case, maximum moment, because it gives us two things, theta and also x. So there should be two conditions that fit the condition. So the first one is the axis of the distance. So the first condition that has to be met is the axis of the distance perpendicular to F. So as you can see from the diagram, this is the axis of the distance. I mean the structure of the crane. This is the structure of the crane, and this is the force direction. So as you can see, this is not perpendicular. So you guys have to lower the crane so that it would be something like this. Okay, you guys have to lower the crane so that it will be perpendicular to the force. So as you can see, this is theta. So if you lower the crane, what would happen to the theta? The theta is supposed to have value originally, but when you lower the crane so that the crane would be perpendicular to the force, then the theta would be 0. Okay. So therefore, the first condition is the axis of the distance perpendicular to F, which means that the theta will equal to 0. Okay. And the second part is we have to choose the value of x. So in this case, the value of x, as you can see, we use the formula m equal to fd. So as you can see, there is d here. So what that means that the larger the value of distance, that means the larger the value of moment. So in this case, since the largest value of x given is only up until 5 meter, so that means maximum moments occurs when uh, x value at is max. Therefore, x equal to 5. So this is the answer for the second part. So do you guys have any questions for the second part? Yes, correct. It should be 0. Okay. So this is how. So this is the two conditions that fit the things that the question wants us to find. So if you guys have the angle, the x perpendicular to f, then the theta equal to 0 and x value at its max, so x equal to 5 meter. So then we settle with first part and second part. Now we find the value of moment. The value of the moment itself. This is the third thing that you guys have to find. So using the same formula, since you guys already find the equation from the first part here, you guys just have to insert the value of theta and x. So can anyone give me the answer to the third part, the value of moment? So you guys just have to key in the theta and x value. Sorry, this should be negative here. Miss, where did we get 1.18? Oh, you get 1.18 because you 120. You times with 9.81. That's it. Oh, okay. So 120 you guys times with 9.81, then you guys will get 1177 Newton. So this, as you can see here, I define the unit to be kilonewton. Okay, I define the value, the unit to be kilonewton. So that's me. I convert from the Newton to be kilonewton. So that is how I get 1.18. Okay. Okay. Oh, the value of the moment. No one has the value. Okay. It should be 14.75 kilonewton meter. So this is counterclockwise. So if you guys define the moment direction to be clockwise, then this should be the answer. Okay, up until this part, do you guys have any problem? Are you guys okay with the questions number 1? If you guys okay, we will proceed to the second questions. Okay. Okay, now we proceed with the second questions. So you guys can take 10 minutes to solve the questions. And then after 10 minutes, we will discuss the answer together. So for these questions, I have to explain to you guys first. Okay. So the questions wants us to determine the moment of this force. So the moment of this force about point O. So that means it wants us to find uh, the vector of moment. So vector of moment, the formula should be vector R times with vector F. Okay. So so you guys have to find the vector R and also vector F before you guys could find the moment. So in this case, F equal to F vector equal to F times U vector. Okay. So and then you guys have to find the R vector. So so if you guys find after you guys find these two things, you guys can solve the vector of the moment. Okay. Please try. For questions number 2, so Chia asks whether we need unit vector. So for the value of the moment, yes, we need to find the in terms of vector because it asks us moment of this force. So you guys have to define the value um, of the force in x-axis, y-axis, and also z-axis. So that's why we need to use we need to find a moment in terms of Cartesian vector. Okay, so it's already 10 minutes, so let us discuss the answer together. Okay, so as mentioned previously, the equation that we need to find moment of this force is m equal to m vector equal to r vector times f vector. So we will find the r vector first. Okay, so as you can see, this is the force from A to along to the C. Okay. So and the question wants us the moment of this force about point O, which is here. Okay. So there actually you guys actually two ways you guys can take this. Either you guys take from O to C or O to A. So you guys can choose between these two uh, because of the principle of transmissibility. Okay, so as long as the origin, the point is same, doesn't matter at what point, at what coordinate you guys take along the force. So it can be ROC, ROA, or ROC. It doesn't matter because at the end the value of the moment would be same. So in this case, I will take about along here, ROC. So you guys have to find the coordinates for each point first. So here I already defined the coordinate for O, A, and C. And since I'm looking for distance between O to C, then I will only use coordinate for this one and also this one. So 4i minus 2k will be the r vector in this case. So now we already find the r vector. Now it's time to find the f vector. So f vector we will use this formula. F vector equal to fu vector. So the u vector we because the force is traveling at this point, so the u vector should be uac. And then you guys have the value f is 80 Newton. So if you guys solve this question, you guys would get so this is the value of the f vector. So up until this point, do you guys follow?
Yes, Miss.
Okay. Okay. So since we already have the value of r vector and then we have the f vector, so we can just find the value of m vector. So, can anyone tell me the value of the m vector? Can you guys solve this for me? And when you guys solving the matrix, please be careful for this part. This for J, the this one should always be negative. Is positive I, negative J, positive K. So you guys have to be careful at this part. It should always be negative. So anyone? Do you guys solve the vector of M? Yeah, can you try again? So this is the final answer. Negative 128.28I plus 128.28J minus 256.56K. Uh, uh, sorry if you cannot see the value properly, because it's quite hard writing on the screen here. But if you later if you do this again on your own, you can easily find the value, which value is which value, which value actually you okay. Okay, so do you guys have any problem up until here?
Miss,
Yes.
in terms of finding the value of radius of OC, can we find the radius of O from O to A point?
Sure, you can use that also. You guys for because there is actually two option here. You guys can use ROC. You guys can also use ROA. At the end, the value of the moment would be same. There's no
Okay.
problem.
Okay, thank you, Miss.
Okay, you guys can try using ROA later. Okay, so if you guys okay with questions number 2, then we proceed with questions number 3. So for questions number 3, it wants us to find the resultant moment. So in terms of Cartesian vector. So in this case, we're using the same formula like questions number 2. But since we have two different forces, then you guys have to sum them up together. So since it wants to be about point O, which is here. So for our vector about point O, so this one you guys can either use OC, ROC, or ROB, or ROA. So you guys have two choices here. Any value of R would result in the same value of the resultant moment. So you guys don't have to worry about that. And then you guys have to find the F vector. So since we have two different value here, so you guys have to find a vector for FC and also a vector for FB. So you guys try to do on your own. Okay, so we will discuss the answer to questions number 3 together. So these are the items that we need to find first. The R vector, F vector for force C, and F vector for force B. So we will solve for the first part first, the R vector. So for R vector, you guys have to ensure that it's about point O. So point O is here, and there's actually few choices which value you guys want to take. Is either ROC, ROB, or ROA. It doesn't matter among these three, because at the end the result of the moment you guys get would be the same value, the exact same value. So in this case I will just use R vector for OA, because I can just use for both for FC and also FB, because their origin is actually at the same point. Okay. So for R vector OA, you guys have to use coordinate A and also coordinate at point O. And you guys will get 6K meter. Okay, now we try to find for the F vector B. So the value of FB is 780. And you guys will get 300J minus 720K Newton. Okay, so we settle this one, and now we find the F vector for FC. The value of FC, the force would be 420. And for vector FC, you guys will get 120i minus 180j minus 360k Newton. So now we already have all the values, so we can just sum them up. So moment at point 0, resultant moment at the point 0 would be can you guys solve this part? Can you tell me how what's the value? This is final answer. What's the final value of the resultant moment? So this and this are the value of r vector A you get here, and this is vector FB get here, and this is vector FC you get here. Okay, from this you guys can solve it and you guys get the final answer. While waiting for you guys to give me the final answer, in case if you guys are not using R vector OA, you guys also can actually using ROC and also ROB. So it will be like so the equations if you guys using ROB and ROC it will be something like this. So moment the resultant moment vector would equal to vector ROB times vector FB plus vector ROC times vector FC. So it's either way. You guys can use this one or you guys can use this one. The answer shall be the same because of the principle of transmissibility. Okay. Anyone managed to find the value of the moment, result the moment? So if you guys solve this part, you guys get and you guys solve this part, you guys get oh, this value. So if you guys add this and add this up, you guys will get negative 720 plus 720 G. So this is the final answer. Do you guys have any problem up until here? Do you guys follow? Are you guys okay?
Yeah, okay, Miss.
You guys sure? Because you guys don't sound very confident. So if you guys are using the other options where R vector ROB times vector FB plus vector ROC times vector FC, you guys should get the same answer as well. So this is the final answer. So if you guys okay, we will move to the last questions. Yes, okay. Okay. So this is the last question. So take 5 minutes or 10 minutes to solve these questions, and then we will discuss the answer together. So for questions number 4, it wants us to find moment of this force. So we are using the same formula. M equal to, vector M equal to, this actually, because this is moment of this force about an axis. Previously, the moment of the force is actually about a point, but this one is about an axis extending between A and C. So we are using different formula. So in this case, we are using m vector equal to m times u vector. And since it's about axis extending between A and C, so you guys have to find value of moment at AC and also unit vector at AC. And for these two, you guys have to find the value of MAC, because we don't know the two value here, MAC and also USC. So MAC will equal to U vector AC dot R times F. And then for USC, vector RAC divided by RAC. Okay. Try to solve this. So we solve the last questions together. So as you can see, before we can find the moment of the force about axis extending between A and C by using this formula, we have to find the value of moment and also the value of the vector UAC. Okay, so we will solve the UAC, vector UAC first. So you guys will get the value of vector USC is equal to 0.8 I plus 0.6 J. Okay, so we already have this value and now we have to settle this part. So for F, we already have the value here, already given, so we don't have to consider this. So USC we already have, and now we have to find the vector R. So which vector R that you guys need to use? In this case, because it wants it to be about axis A and C here, and then your force is around here. So that means the R can be along RCB, or it can be like here, RAB. So you guys can choose either one to be substitute here, because at the end the value of moment would be same if you guys RCB or you guys use RAB. So for in this case, I will use RAB. Why do we need vector R? Because this equation. Because of this equation. Okay, you guys, to find the moment of this force, you guys have to use this formula. So for this part, we already find the value. And for this part, we don't know the value yet. So to find this value, we have to use this formula. Okay, this formula. So to use this formula, the formula is actually m equal to m vector equal to u vector times, this is dot product, r vector times f vector. So in the equation itself, it requires us to have vector r. So that's why we have to find the vector r. If you ask so if you ask why we have to use this formula, is different from the previous questions number 3, because the questions for number 3 only m equal to r times f vector. That's because the moment of that force is about a point, like point O, point A, if you notice. But for questions number 4, it wants the moment about an axis. So the condition is already different. So we have to use different formula. So that's why we have to use this formula. And this formula indicates that we have to find r vector. So that's why we have to use r vector in our calculation. Are we clear? Are you okay, Chia?
Okay, Miss. Just the axis. If involves two axes only, then we only use the r vector, right? Is that the meaning?
Actually, if about a point also, you guys have to use r vector. Like, if we back to questions number 3, it is also use r vector. M equal to r times I vector. So for questions number 4, is still using r vector, but you guys have to add the u vector here because it's about an axis. Are we clear?
Okay. Okay.
Okay, thank you.
Thank you. Thank you, Miss.
Okay, so this is the value r vector AB. Okay, we already have this value, and this value. So we can directly plug in the value to find the moment MAC. Okay. So the first row, you guys fill in with u first, this value. And the second row, you guys fill with RB. Which is here. And the third row, you guys fill with F value, which is here. And if you guys solve this, you guys would get 14.4 kilonewton. This one is directly the value itself is equal to 14.4 kilonewton meter. So this is what you guys get if you guys solve this one. Do you know? I believe you guys know how to solve this one, right? If no, can you guys please tell me, because I believe this is going to be in your exam how to use the matrix. Yeah. Okay. If you guys don't understand, tell me. Okay. Okay. So we got this value. We got this value. So now we can find the moment of the force. So MAC we have here 14.4, and then UAC. U vector UAC we have it here. So 0.8 I plus 0.6 J equal to 11.52 I plus 8.64 G. Kilonewton meter. Okay, so this is the final answer. So do you guys follow up until this point? Yes, Chia, do you guys do you have any questions for me? Oh, okay. Oh, this need just now. Okay. All right. Do you guys follow? Okay. Because the tutorial time is 2 hours is not actually enough to properly explain to you guys, like the questions properly, and you guys have exam next week, right? So if you guys when you guys go through the tutorial questions and you guys have questions, you guys can just drop the questions in the chat. I will reply to you guys, because right now maybe some of you not fully follow the tutorial. I mean, okay. So later when you guys prepare for your exam, if you guys have questions, you guys can just drop the questions in the chat. I will reply to you guys. Okay. Uh, why still can get the answer for MAC while use RC peanut RAB? This one is questions for number 4, right? MAC. MAC while I use RCB.
Sebab dia dekat line dengan B tu kot, selari, sebab tu dia dapat jawapan yang sama. C dengan B kan
you mean
atas.
you mean this one
RAB dengan RCB tu.
You guys supposed to get same answer because I calculated before. Oh, wait. Okay. So I assume you guys okay up until this point. So we tried to solve the question using RCB. So when you solve for RCB, you would get you guys have plus right after this. Okay. This you get negative 2k. Okay. So if you from the value You should get something like this, right? So I don't have enough space, so I don't write the matrix. This should equal to can can you guys verify whether this part we have same value? I mean the calculation steps. 24. Can you verify this part? Do you guys use minus or plus? This part. Do you guys use plus or minus? Because this is from the vector j, so it should always be negative. Oh. So it should be positive 0.8, and then this one negative 0.6, and positive plus 0. This is for the k when you try to multiply at the k, like k here. This one, so when you try to multiply for j, it should be negative. Okay, can you guys try again? And okay, so last week I didn't properly explain to you guys for questions number 5 because we don't have much time, and I plan to explain it properly to you guys today, but since we only have 3 minutes and most of you guys have class right after this, so I will just explain to those who don't have class. So who has class, you guys can come back and see the recording. When you guys see the recording and you guys don't understand, you guys can drop the questions in the chat and I will answer to you guys. And for questions number 4, this one, for tutorial 3, this one, can you guys try again and see whether you guys can still get 14.4 kilonewton meter. It's supposed you're supposed to get the same answers. Okay, because it's the exit extending between A and C. So any point between A and C, the distance to get to the B, you guys should get the same answer. Okay. If okay, that's it. Okay, I will for those who don't have class, can you stay with me for 10 minutes? I want to explain questions for last week, number 5 and 4. And those who have class, you can leave, but come back later and review the recording. Okay? If you guys still have questions, you guys please ask the questions in the chat if you guys have questions, because next week you guys have exams, so I believe you guys need some input. Okay, thank you. For those who have class, you may leave for your next class. Okay, so only this remain. Okay, I okay. Okay, thank you for staying, even though only few of you guys. Okay, so basically I want to explain now for questions number 5 last week, because we don't have enough time last week. So basically this is questions from last week. As you can see, the crate has a mass of 130 kg. That would make so we draw a point here, and then so that means the force downward would be 130 times 9.81. Okay, and then it wants us to determine the tension developed in each cable. So guys, so we have 3 tension. Okay, so to find tension here, FA, FB, and FC here, we use the formula. Okay, we use this formula, F vector equal to Fu vector. So for all 3 forces, Fa, Fb, and Fc, you guys use this formula. Okay, if you guys find the value, we find the value of Fad first. By using this formula, you guys will get this value. At least, okay, since we don't know the value of F, A, B, C, and D, we maintain the unknown in the equations. So we do the same thing for FB. FB, we use these equations, and then you guys will get negative 0.8 I minus negative 0.4 J FBD plus 0.4 FBDK. Good. This also we have unknown here because we don't know the value of FD. And then we find the equation for FCD. Okay. By using same equations, this is what you guys would get, 0.66 plus 0.66 FCDI plus 0.66 FCDJ plus 0.33 FCDK. Okay. So basically, we don't know the value of the forces yet, because I mean the vector of the forces, because we still don't know the value of the forces. Okay. So, and then the force pointing downward is negative. I'm sorry, it should be 1 here. Okay. It should be negative 130 times 9.81, you guys will get negative 1275 Newton because it's pointing downward. So, since this is for equilibrium, so to find the unknown forces, the tension here, you guys can use this assumption. Sum fx equal to 0, sum fy equal to 0, sum fz equal to 0. Okay, so basically for so we settle the first part here, sum fx equal to 0. So the value for sum fx, you guys, okay, the value here, here, and here, you guys take from the equation here, the one with I vector here, here, and here. So this is where all this value come from. So since there are three unknown in the equation, so we cannot solve this yet. So you guys can just simplify the equations into one unknown as the head of the equations. So this is equation 1, and then we try to do the sum fy equal to 0. So for sum fy equal to 0, the value here, 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 we take from the equation here, the one that in the j vector, this one. Okay. Since this also have three unknown, we cannot solve this yet. So you can simplify, making one unknown as the head of the equations. So and then you can see this one FAD equal to FBD plus 0.8 FCD equal to 0, and this one also you guys have FAD as a head, so you guys can equal them up together. So when you have equal them means 1 into 2, you will only have two unknown in the equations. Okay, and then this one is equation 3, and then you sub this equation 3 into the equation 1, so that we can have another unknown as the head. So when you can simplify, you guys will get FAD equal to 1.2249 FCD. So we already have 4 unknown up to here. So and then we solve for the sum of the fx equal to 0. So for sum fx equal to 0, you guys, okay, take the value here, the k directions, and also here, because the mass times gravity is pointing downward, that means it's actually in the k direction. So you guys will get the equation like this one. This would be equation 5. Okay, so when you guys substitute the equation 3 and also equation 4 into the equation 5, you guys will get only one unknown. So when you guys only get one unknown, you guys can find the value of FCD. In this case, it will be 1275.3 Newton. Since we have FCD, you guys can just substitute the value of FCD into equation 3. And then we get the value FBD equal to 5 to 0.8 Newton. And since we already have two value we already got, so now we can settle for the last value, FAD, using the equation 4. So FAD equal to 1562.1 Newton. So this is how actually we solve a problem for questions number 5 last week. So are you guys follow? Okay, I hope so you guys follow. Why fy fx fz equal to 0? Okay, basically this you can get from the equation. You can get from the questions, because it says determine the tension developed in each cable for equilibrium. So when you guys found this word equilibrium in the questions, it means it's directly means some fx equal to 0, some fy equal to 0, some fz equal to 0. So this is how important for you guys to pay attention to the keyword in the questions, because it's equilibrium. So that means uh, all the forces shall equal to 0. So even if you have like in these questions, you have forces pointing downward, right? Negative 1275. We have forces at the point, but it should equal to 0 when you guys add the tension FA, FB, and also the forces pointing downward here, it should equal to 0. So it's like reverse calculation, because at the end of the day, it should be equal to 0. So it's somehow like a reverse calculation. So that's why when you guys see equilibrium, that means all forces equal to 0. Okay. All right. And actually, we settled with questions number 5 from last week, but I also want to explain for questions number 4 from last week. So if you guys don't mind, please stay for another 5 minutes. Okay. Um. Okay. Basically, same as questions number 5, because okay, because we still need to find the tension in each cable, and the state of the cable, the point A, the state of the point A here is in equilibrium, which means, which has the same meaning, which means that the sum of the forces in all direction fx, fy, and also fz is equal to 0. Okay. Okay. So first, you guys have to get the coordinates first. We get coordinate for A, B, C, and D. A is 005, B is 440, C is -230, D is -4, -5, and 0. And FA is pointing upward, so it should be positive 800 Newton. Okay. Okay. So since the only value other than force that it gave us is the coordinate here, so you guys can use this formula to find the equations for of the tension, like force here, this is force pointing upward, so we have force here, this is force FAD, so pointing in this direction is force AB, and pointing is in this direction is FAC. Okay, so using this equation, so we find the vector FAB first. Vector FAB equal to FAB times UAB. Okay, so coordinate B minus with coordinate A Okay, you guys will get this answer 0.52 FABI plus 0.5 or 2 FABJ minus 0.66 FABK. Okay, and then using the same formula we find the vector FAC. So this one is for FAC is coordinate C minus A. Okay, so you guys will get negative. I'm not sure if you guys can see it, but this is actually negative. Negative here. Negative 0.3 FACI plus 0.48 C67 FACJ minus 0.811 FACK. Okay, and then we find the vector FAD. Okay, this one, so using the same formula. So for this one, coordinate D minus coordinate A. So you guys will get negative 0.49 FADI, negative 0.61 FADJ, minus 0.61 FADK. Okay. So we will take advantage of this keyword, equilibrium. So the sum of all forces should be equal to 0. So first we try to solve sum of fx equal to 0. So okay, for the equation of this one, the value you guys take from the I vector here. I vector from FAB, I vector from FAC, I vector from FAD. Okay, you guys did get these questions. So and then you guys simplify so that only one unknown become the head of the equation. Okay, so you guys get FAB equal to 0.61 FAC plus 0.9 FAD. This is equation 1. Okay. Okay, so we settle for sum of all forces in y directions equal to 0. So for value in the y directions, you guys take from the j vector here. Value from j from FAB, value of j from FAC, value of j from FAD. Okay, so you guys get these equations, and then you guys simplify it to be one head as the head of the equations. You guys get equation 2. Okay, so now you guys get equation 2. You guys equal FB, you guys make it equal FAB equal to FAB. So we will get oh, I'm sorry, FAC equal to 0.15. Okay, I'm sorry, there's some mistake here. So when you sub 1 into 2, you would get actually FAC equal to 0.1518 FAD here. Sorry, this should be FAD. My mistake. FAD. Okay. So you guys get equation 3. Okay. So you from the simplified equation here, 3, you guys sub into 1. And then we get another simplified equation. FAB equal to 1.0223 FAD. This is equation 4. Okay. So when we settle up until here, now we solve for the forces in the x direction. So for forces in the z direction, sorry. Okay, you plug the value from here, and from here, and also here, because this is in the in z direction. You guys will get equation 5. Okay. Okay, so using simplify equation 3 and 4, you guys plug it into equation 5, you guys will get the value of FAD to be 565 Newton. And then since we have FAD, you guys plug the value FAD into equation 4, you guys will get FAD equal to 578 Newton. And then since we already have two values, you guys plug the values into the equation 3, FAC equal to 85.8 Newton. So this is the final answers. So do you guys have any problem with the questions and answers? Okay, so thank you for staying for 20 minutes. So if you guys have any questions during studying for exam next week, so you guys can just drop the questions in the chat. I will